Hello and welcome to the evolution of stars for Science 30, the physics unit. The temperatures of stars. Stars appear to be different colors when they are looked at with the unaided eye. The hottest stars, between 112,000 and 97,000 degrees Celsius, have their peak in the continuous spectrum within the ultraviolet region. Our eyes see these stars as bluish white. Our sun appears yellow because it is cooler. It is about 5,500 degrees Celsius. Even cooler stars, which have a temperature on average of 29,000 degrees Celsius, appear to be red in the night sky. The evolution of stars. Current theories explain a star's spectra and color in terms of its mass and stage in stellar evolution. All stars begin in regions that are rich in hydrogen and dust, but their life cycles depend on the original mass of the star. Stars are classified as either low mass, like our sun, intermediate mass, or high mass. The evolution of stars. In the beginning, all stars begin as a ball of dust, hydrogen gas, and plasma, which is called a nebula. Nebula often form star-forming regions. In these regions, the formations of gas, dust, and other materials start to clump up to form larger masses which attract further matter and eventually become big enough to form stars. The remaining materials are then believed to form planets and other planetary objects. There are a couple of different nebulas that we are going to see pictures of. The first is a flame nebula because it looks like there's a flame in the middle. There are the Eagle Nebula, also known as the Pillars of Creation. This is the Horsehead Nebula because it looks like it has a horse head. And the Omega Nebula. The evolution of our sun. A low-mass star. Low-mass stars spend their main sequence lives fusing hydrogen into helium in their core. A low-mass star is one that has a mass that is not more than 1.4 times the mass of our sun. The life cycle of a low-mass star. Nebulas form low-mass stars, then as the fusion materials start to run out, they become red giants, white dwarfs, and eventually a black dwarf, although we cannot see a black dwarf in our universe at this time. What is a red giant? A red giant occurs when the core or helium fusion stops and hydrogen fusion occurs in the outer layer. The core will heat up and contract, compressing the hydrogen above, and increase the rate of fusion. A star becomes 1,000 to 10,000 times brighter and expands. The temperature of the star decreases, causing it to look orange or red. A white dwarf occurs when the outer layers of red giants are shed as planetary nebula. The mass is comparable to the sun, but the size is comparable to the Earth, so these are quite dense. Light comes from stored heat, but no energy source is present, so there's no fusion. Eventually the heat will disappear, and the result will be a black dwarf. None are known to exist in our universe right now. The evolution of a high-mass star. The evolution of intermediate and high-mass stars. Nebula form intermediate mass stars, then form supergiants. At the end of its life cycle, an explosion or supernova occurs, and that eventually forms a neutron star. Nebulas, for high-mass stars, nebulas form a high-mass star. Then as the fusion materials start to run out, form a supergiant. Eventually those supergiants collapse into a black hole. Intermediate and high-mass stars. The definition of an intermediate star is a star that has a mass of approximately 1.428 times the mass of our sun. High-mass stars have a mass greater than 8 times the mass of our sun. Supergiant stars are part of the evolution of an intermediate and high-mass star. It has a core temperature of approximately 3 trillion degrees Celsius. It occurs when the hydrogen fuel is used up at the core of the star. A supernova is a stellar explosion that produces a bright cloud of ionized gas that remains very bright in the sky for weeks or months. It can radiate as much energy as the sun can during its entire lifespan. The results from the gravitational force within the star This results from the gravitational forces within the star compacting at the core. A neutron star is a superdense star consisting of mainly neutrons, formed as the last stage of stellar evolution of intermediate mass stars. A single spoonful of a neutron star would weigh approximately 907,000 tons, so it's very, very dense. What is a pulsar? A neutron star spinning rapidly on its axis is called a pulsar. It emits radio waves, and this radiation can only be detected if it is pointed towards the Earth. A pulsar in the Crab Nebula is thought to be the remains of a supernova explosion visible from Earth from 1054 AD. Black holes are an area of space in which the gravitational field is so strong that neither matter nor any form of electromagnetic radiation can escape. It's the last stage of the evolution of a high-mass star. It consumes surrounding matter as the matter is pulled into the gravitational field. It's found by watching the effects of matter on the